Number 33, for Honors Algebra 2, we have a system of 3 equations and 3 unknowns. So, in a case like this, you have 3 variables and 3 equations. You want to start by eliminating one of the variables. There are different options of how you can start, but you need to pick one variable to eliminate from both equations. So, for example, if we choose to eliminate the x's, if we take the second 2 equations, to eliminate x, we would need to multiply the third equation by -4. So the first equation we would have is this, unchanged. Multiplying this by -4 would give us -4x, -16y, minus 4z equals -88. Combining those would give us -18y minus 8z equals -96. So we have an equation with y and z. I'm going to hold on to that and come back to it later. If I have one equation with y and z, I need another equation that also has y and z. So I'm going to eliminate x again in the first 2 equations by multiplying the first equation by 4 and by multiplying the second equation by 5. So canceling the x's, we get 2y minus 12z equals -28. We now have 2 equations that both have y and z. And so we now have a system of 2 equations. So -18y minus 8z equals -96. 2y minus 12z equals -28. So if we want to cancel the y's, we just need to multiply this second equation by 9. That would be positive 18y minus 108z equals -28 times 9 would be -252. Now combining these 2 equations, we can eliminate the y. So the -116z, and then -252 minus 96 is -348. Divide both sides by -116 and we get z equals 3. Now that we know z, we can plug back in and find y using any equation that has y and z. So 2y minus 12z, so minus 36, equals -28. So add 36, that would be 8, y equals 4. So z equals 3, y equals 4. Looking at the original problem, you can use any of those equations to solve for the third variable, to solve for x. So I'm just going to use the third one here, x plus 4y plus z equals 22. So 22 minus 19 is 3, and we have our solution x, y, z. X is 3, y is 4, and z is 3.